Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So thank you, Andrea, for introducing myExperiment. Some of you may have heard previous talks, and I'm going to start with this picture, which is the picture I used when I spoke last year about the use of myExperiment for accelerating science. And then for those of you who haven't come across myExperiment before, I have a few slides that introduce that, but then I'll be moving on to this notion of research objects, which is what I'm talking about today. So this is a fairly iconic eScience picture. This was actually drawn by Simon Coles from chemistry in Southampton. It's been used by many people. Possibly some of you in the room have used this picture as well. And the main point of the picture is that eScience cyber infrastructure has sometimes had a focus on the data deluge that occurs around the new experimental techniques, the DNA microarrays, the combinatorial chemistry, the scientific workflows, the sensor networks, the Earth observation, and so on. But really, if you want to think about the whole process of accelerating science, doing new science, doing data-intensive science, we need to be more holistic and look at the overall life cycle. And this is the sort of traditional science 1.0 scholarly publishing cycle with things going out through repositories and journals and coming back into the labs, but also to the next generation of researchers who are very important on the right. And the things behind myExperiment is this observation that in this increasingly digital world of research, we have all these new kinds of scholarly artifacts. The data, we've talked about a lot, the metadata, the provenance records, so you can trust things and interpret them, scripts and workflows, the services and service descriptions, ontologies, vocabularies, blogs, and all these pieces, all these things that Ben was alluding to this morning, talking about Science 2.0. And how do we share those things? So myExperiment is an experiment to explore the sharing of those pieces in a Web 2 kind of way. And normally when I present this, I say, we're going to look at the right-hand side of this picture, and it's important that it's over on the right-hand side because this is also where the next generation of researchers are, and that's our emphasis, and that one day we're going to look to see how the right-hand side fits to the left-hand side. And today, I'm going to do the right-hand, left-hand thing. But first of all, for those of you who haven't come across myExperiment, it all started with Carol, who's my co-author and is sitting at the back, waving at me, who back in 2006 came up with the idea of myExperiment, I think in keynote talks, and it got a lot of attention, including from here, the MySpace for the dudes in lab coats. And the issue that was arising then really, and we still feel it quite a lot, is this sort of suspicion that Web 2 isn't the right thing for scientists to share. Rob Stevens in Manchester at the time observed there's a great collaboration tools that 12-year-olds are using. It's all back to front. And that's really the issue. It seems that the teenagers were able to share stuff in a way that we wanted scientists to be able to share, but the scientists weren't using those tools. And there was this real suspicion that there were good reasons for that, because scientists fundamentally don't share. There's many quotes like this that allude to that. But we suspected that they do. We've just seen the scholarly knowledge life cycle in the earlier slide. The whole process of science is about sharing at some level and building on what people have done before. And there are sites like Open Wetware which mandate that everything on those sites is public. And that was growing organically. So there was some evidence of sharing. So myExperiment partly is an experiment to see if scientists really do share. It's also an experiment in lots of other things, as you'll see. So when it comes to describing myExperiment, we talk about it in different ways to different people depending on the audience. And today we've actually got just about all possible members of our audiences in one room. So some of you are researchers. Here's a researcher. These are the blind monks seeing different bits of the elephant that is myExperiment. So there's a researcher clutching the trunk there. This is a social networking researcher, clearly because he's got his hands on this other researcher. There are developers underneath the elephant. Okay. There's a Web 2 guy up there, and I don't know why I put open repositories at the rear end, but I apologise to anyone in the room. So we started by calling it MySpace for Scientists, because that's what neuroscientists have done in the press release you saw earlier. And then we decided that was rather passé, so we talked about Facebook for Scientists, and then we said, no, it's not Facebook for Scientists, right? Because of that thing I just mentioned, that people assume that Web 2 means everything is public, and that isn't what scientists want. So now when we describe myExperiment, we say it's Facebook for Scientists, but different to Facebook. So it captures the whole idea of Web 2, but it has a load of other important properties which we're going to talk about. And for repositories people, it's significant that it's a repository of research methods. There's a lot of emphasis in repositories on data, and that's very important. But along with this data deluge we also have the method deluge that's being used to process that data. Isn't that just as important? What about the curation of those methods? So we have this emphasis on method, which we think is very important. Sharing methods shares know-how, builds capacity, enables new science. Okay? It's an interesting social network because it is a social network of scientists with friends and groups and so on, but also of the things that they share. And we're interesting to the social network analysis research community, people like Nosh Contractor, because of the way that's evolving. In the UK, we have this notion of the virtual research environment, which is like a collaboratory, and this is distinctive for being social. This is social infrastructure. So these are all the sort of different things we are. If we're a developer, we're an open source Ruby on Rails application. As you can see from the dates there, it actually came together very quickly. One of our key developers is sitting in the front here, Mark Walkham. We spent less time writing code and more time with the users by using a web application framework like Ruby on Rails. We put a lot of work into making it usable to developers as well as to the end users, and you'll see some examples of that later on. So now we have about 2,500 members. The members are the people who actually have accounts on the site as opposed to the users who are all the people who might have found stuff on Google or seen the URL on the end of Andrea's slide and just downloaded something. And we've got 200 groups, 800 or so workflows, which makes it the largest public collection of scientific workflows. And then we have files and these things called packs, which I'm going to come back to in some detail. And in terms of, from Google Analytics, the number of unique IP addresses, sort of 36,000 or so people uniquely have downloaded stuff. And you can go away and look at the site now if you've had enough of me. What you'll see is a familiar sort of Web 2 interface, tabbed interface. Significantly, perhaps, this yellow stripe, this sidebar here, carries what we call the social metadata. This is things like the credits and the attributions and the license. These are the things that scientists really needed to be there in order to be willing to use the site. It manages the rights flow, it manages reputation, and that's absolutely essential. So that's perhaps one of the key things there. I won't talk much more about the site itself. What I want to do in a few slides quite quickly is to give you a sense of the results of the experiment that is my experiment. And then I'm going to go on to the PACS thing. So these are the distinctives of my experiment over a site perhaps like Facebook. There is a focus on the credit and attribution. There's this fine control over the sharing and the privacy that Andrea mentioned. The PACS, I'll talk about the fact that you can have multiple ones of these things. There isn't just one site. And the fact you can actually run stuff in them as well, which makes them in the digital libraries world a second generation digital library. It turns out I discovered at JCDL this year. I ought to put that on my elephant. The packs are important. One of the principles of Web 2, going back to sort of the O'Reilly definition that we heard about in the keynote this morning, is data is the next Intel in science. This is saying that YouTube does movies, that Facebook, that the Flickr does photos, that SlideShare does slides. So in a sense, it looks like my experiment set out to be the site that really, really knew how to do workflows. And it does that, but it's called my experiment. It's actually about experiments. And scientists don't work with a single content type. Scientists, researchers in all disciplines, work with bundles of stuff. Okay? And that's why we introduced this notion of packs. It's the idea that once you've downloaded a workflow and run it, you've now got some input data, you've got some output data. You do some research, you write a paper, you have some slides. This is pack 55 or 56, I think, Paul Fisher's pack from his trypanosomiasis work. And that's, from a user interface viewpoint, a collection of stuff that you can achieve through a sort of shopping metaphor. It's like collecting things together in a shopping basket or a wish list. The things don't have to be on my experiment. These can be pointing at external content. But we have got this aggregation of stuff. And perhaps that's the first-class citizen. Perhaps that's the thing the scientists really need. That's the thing that captures the experiment. It seemed a bit odd when we started that there wasn't a standard to represent this, because it's like a standard for a bundle of URLs. You'd think that would exist in the web. And it's another discussion. But then, fortunately, ORE came along just at that moment. I'll come back to that later. So that's what we have in my experiment at the moment. You look at packs, there'll be these bags of odds and ends which are on the site or elsewhere, so you can capture all the right versions of things and have a unique URL pointing at that. Now the results of that sharing experiment, do scientists share? Well, the good news is they do, as we suspected, and in other talks, especially ones given by Carol, you'll get a much greater analysis of this aspect, and this is what we talked about previously. It isn't the focus this year. The sort of relationship between the consumers of things like the workflows and the producers is much more characteristic of a site like Wikipedia than it's not an 80-20 thing. You have a very large percentage of consumers, a very, very small percentage of producers, and this hugely important group in the middle, which is the group that over time at the moment we're trying to grow, because they add a lot of value to this and do the magic which you get from human beings participating in all of this and giving the network effects, are the people who are actually adding value to the content by keeping things up to date. For example, the popular workflows will be maintained, still be usable by the people who are using them. That is then shared with the others. So this is quite an important sort of, 90%, 9%, 1% type of distribution. But that's another talk. Now, this is all like a probe on how scientists do work. It's very interesting from a social science viewpoint of view. Like, we give people a small number of mechanisms. You form groups, you form friendships, you can build packs, and then we let the community loose with it and we watch how the content evolves. That's very interesting. So here's a few glimpses quite rapidly of what's gone in there, and then we'll look at the packs. So other people have introduced their own workflow systems. There's a couple here. You can configure myExperiment to run workflows as well locally. So people are actually not just sort of uploading and downloading workflows in their formats, but they're making it possible for their users to actually run the workflows from myExperiment. We get a glimpse not only into the sort of different types of workflows that are being uploaded, but through that a glimpse of the research people are doing and what's going on in the sort of innovation in that area. This is a particularly nice one for semantic people in the audience, although they're probably in a different session, which is Francois Bello, who's writing workflows that do Sparkle queries to get things from RDF and linked data stores, puts them into a store, does a query and gets a result. It's a very powerful way of assembling things, and we're really beginning to see, just over the last few months, this being used increasingly in eScience. So that's a nice, interesting example of semantic science in action. We also see people installing new instances of myExperiment because they want to develop them for their own community or add their own functionality. The one at the top here is from a project called Ofpace, led from Oxford, which is marrying the high-performance computing community with the numerical algorithms community. The astronomers, not content with calling something Facebook, preferred Spacebook, and have worked on that over myExperiment. There's an instance of myExperiment at Monash, which some of you will be aware of, which supports Nimrod, working towards Kepler workflows. And then, very interesting, as well as bringing the users to the myExperiment website, a nice, friendly, familiar sort of website, or as well as making it possible for people to make that website available elsewhere, by building over the API, you bring myExperiment functionality through in the researcher's environment. So instead of them having to learn anything new, you can get that coming through into what's very familiar to them already. A very important one of our principles to bring myExperiment to the user rather than vice versa. So if you are a Taverna user, as we heard from Andrea, Taverna 1 and Taverna 2 have plugins which enable you to get at myExperiment functionality from within the Taverna workbench environment. If you're an iGoogle user, you can get bits of myExperiment functionality. These are great. These little Google gadgets, we use this as a teaching technique for summer schools and for undergraduate students. And Mark here can teach you REST and iGoogle and myExperiment in 40 minutes, and you can build one of these. We've done that repeatedly. They're really good. So that gives you an idea of how easy it is to sort of build mashups over these things. Here's a Windows 7 interface, which it comes through very, very, very naturally, very easily through the myExperiment API to actually bring that through in the deeply familiar environment of Windows. And having said myExperiment isn't Facebook, here is one of the two myExperiment apps for Facebook. One was written at ISI, one was written in Southampton. So that's possible too. Now let's look at these packs. Right. So this is a mechanism that has enabled people to bundle arbitrary stuff. What are they bundling? So there are things on there like a bunch of workflows that you use if you were downloading and using Taverna 1.7 or Taverna 2. We have things relating to specific pieces of research. We have all the bits of a paper. This is actually a myExperiment paper for concurrency, practice and experience, which uses within it Paul Fisher's trypanosomiasis workflows, all of which are in another pack. So there's a pack containing a pack, so we can do that. Benchmarking for workflows as well. And then, of course, all Carol's keynotes. So all sorts of things get collected together in the packs. We're beginning to get a sense, as we interact with the community and look at the use cases for these, about what it is that people want to express. And it's more than a workflow. Okay? It's all these other bits and pieces. It's the configuration and the results, it's the provenance and the publications, the training material, the version history, everything that you need, so you can come back and have everything that was used for that run of that experiment at that point in time. Paul's pack, for example, is currently, looks like that as we saw earlier. But what Paul really wants to do is say, actually, these things are connected together. There's some relationships between them, and we can put names to those relationships. And they may be from a standard vocabulary, or they may be something that Paul's invented, or maybe something specific to the domain. So we want to have something richer than the packs in terms of expressing these things. And we've seen some good examples of compound objects like this from Jane Hunter in this room earlier today. So these are our use cases. And in order to implement those, in order to actually export these richer packs, we've extended the myExperiment architecture, as you can see here. This thing on the left is myExperiment as we know it. It's a Ruby on Rails application, runs over MySQL very effectively. These are the things that are sort of very specific to myExperiment. The Web 2 principle of cooperate, don't control, reusing other stuff as much as possible and making your own stuff as reusable as much as possible means that these are the things that we do, and then other people can reuse that and we can reuse other people's stuff. Now, if we wanted to start exporting bits of myExperiment content like the packs, we could do it directly from here. In fact, you can do some of it directly from here. But as many of you will know, the nature of this agile world on the left, this perpetual beta world where we're being very responsive to user requirements, is that this is actually quite a fluid world. And also, and this is again characteristic of these frameworks, stuff required up the top there in the interface does have an impact down the bottom here. So there isn't a really, really stable data model here. I mean, a lot of it is stable, but it's subject to change as the whole thing evolves. And evolution is important. So what we do is map across the content in a sort of sync operation that goes through an important transformations to tidy it up. The content so that people can access it in this RDF triple store. Now this architecture is actually quite important. It seems sort of obvious, or it seems like we've added that thing on the right. But the following two scenarios would have been wrong. We could have changed this on the left to have that data model or to use RDF underneath. That would have been disastrous. Or we could have taken a triple store and tried to build a Web 2 interface over it. That would have been disastrous too. There's plenty of evidence in the community of why those are bad ideas. This sync model is actually working incredibly well. So that means we can have a more stable ontology over here, the myExperiment ontology, which I'll talk about. We can query it gracefully over a Scramble endpoint. As soon as we have this up and running, we started getting support queries on the thing on the right. And we put this up as part of our development of research objects, these packs, these enriched packs. And we also put it up partly as a service to the healthcare and life sciences community because we engaged with that within WPC. And it really had a lot of takers. A lot of support queries come in over here. So it turns out that, again, it's an example like the work I was earlier, people were really getting into these Sparkle queries to get exactly the content we're looking for on the site like myExperiment. So we can export packs in our R8s, would be deeply familiar to many of you. You probably have an image like that in your slides. But we want something richer than that. So what we bring in to the ontology is ideas from, first of all, Swan, from Tim Clark at Harvard at the top there. And that's quite interesting, because that's a scientific discourse level ontology. So as well as expressing the relationships between the pieces in these packs, we also want to know how we can express the relationship between the packs and between the workflows. We're trying to capture all of that. It's different on the projectors in my laptop, but those are some of the relationships in the ontology. In Swan at the top, we can debate later what aroused from these in the third column there. And then underneath we have the open provenance model. There's now W3C provenance incubator, which I know at least two people in the room are involved in, which is one thing we'll be looking at. And that's taking ideas from OPM, which has been developed by the Providence research community with a number of challenges over 2 or 3 years, and bringing those through as well. So what we end up with is an ontology for myExperiment, which has some specific myExperiment things that capture the data model on the earlier slide in a stable way. You have bits of shock there, semantically incident online communities, and ultimately, really this set of different pieces coming into the myExperiment ontology. So you'll see doubling coin there, you see friend of a friend, shock, ORE, Creative Commons, all those pieces in there. There's a paper about this at the International Semantic Web Conference next week in one of the workshops. Now, what we've just seen is the ability to export a load of RDF that describes some content that scientists are using. And that isn't the first time you've seen that. In fact, it's happened in lots of presentations. So yesterday, the Zentity being presented in tutorial. Does that look familiar sort of picture, rather like my earlier ones, with a generalization of it? Okay. Here's a picture from David Shotton in Oxford, which I think is quite useful, because what he's saying is let's enhance publications with this semantic enrichment, so you can do some of the things that we're describing. And what this captures is this, we have this sort of intermovement of a problem. Some people are coming at this from the paper end, and the publishing end, and the open repositories end, and saying, how do we augment that to become these new shareable things? We in myExperiment are coming at it from the other end and saying, what is it that people want to share to do data-intensive science? And we're finding that out by watching the evolution of how people are using this site. It's all the same problem, coming at it in different ways. Here's another example. This is Zotero. I don't know how many Zotero users there are here. So, look, Zotero. Searching in myExperiment, there were many other places. This little things appeared in the bar up there. I can click on that, and I've just captured this into Zotero, into my collection there. So that workflow is now part of that, and I can get a number of workflows together. And interestingly enough, from there, this is a Firefox plugin, export it as RDF. Then we have another piece of RDF to Scramble it. So there's plenty of this going on. And what I want to do just to finish the talk is elevate that from that level of discussion where, yeah, clearly RDF is a good way to describe these bits, to say, hang on, what is it that we're sharing here? What are these new shareable objects that are evolving in myExperiment, that are emerging in lots of people's talks? What are these things that we will be sharing with data-intensive science in the future? What are their behaviours? What are their requirements? How are we going to build the tooling for these? How are we going to specify these? So stepping back, and remembering we're doing all this for research, then here's a suggestion. Here's 6 hours back. Another talk's managed to go up to 7, 8, or 9 hours. Today we're in a 6-hour talk. And these we think are actually properties of the research that people want to do in data-intensive science, and therefore the behaviours of the research on that. So Replayable is interesting because in this automated world of data-intensive research, something might happen in 3 nanoseconds, or it might happen in 3 years. And scientists may need to replay a bit of that to have a look in time at once. So being able to replay things is very important. We all understand that we want to be able to run the experiments again, perhaps in different contexts for the scalability of data-intensive science. It's very important to be able to repeat things, perhaps in lots of different places, perhaps all at once. But as scientists in the room know, reproducible is something different to repeatable. Reproducible is independently, as a third party, seeing if they can reproduce the results that someone else has claimed based on the same methods, materials, and circumstances, and so on. So that's an important part of the scientific methodology. They should be reusable in the sense of that it will be done as a black box. One workflow can call another workflow, one script can call another script, or another workflow, or whatever. So we can assemble these pieces and do new science. But also, not just black boxes, we can take the lid off. They should be sufficiently self-describing that you can understand the use of the pieces inside for reuse, and you can reconfigure them as well. That's another one of my reconfigure. So repurposable and reusable are related to the self-description. They're reliable in many senses, in a scientific sense, and they should be robust and systematic. But also to work in this highly automated world that's been discussed earlier today, where the humans out the loop. And those of you who work with data at the moment, your science know how important it is that humans are in the loop, particularly for things like quality, error handling. Imagine all being replaced by a computer and trying to trust the results. So these are key characteristics which we suggest these new shareable objects will need to have in the future. In the discussions we've had about this over the last year, Lots of different characteristics have been discussed which are needed in order to achieve the behaviours on the previous slide. I'm not going to go through these in any detail, but I want to mention one because it ties back into this debate about the relationship between papers and research objects. Because one of the things about papers is that I can look at a paper in a completely different discipline. It's not familiar to me and make some sense of it. I know what it's about, I know it's different discipline. I recognise the title and the abstracts and some other terms and so on. So we don't intend that everything should be able to understand everything about one of these research objects, but rather that you can make enough sense of them to be able to reuse them. And that's very important if we're working with increasingly multidisciplinary research. So that's a particularly interesting relationship. Moving to close now. The way we're taking this forward is to look at what the objects are under a set of different projects. Now, these projects all would loosely fall under the category of laboratories. They were related to myExperiment and to learn one way or another. I'm sure all the projects that you're involved in would probably also fall into this category of laboratory. And just observing that it varies from project to project, but roughly you get a life cycle a bit like this. We certainly see this in myExperiment, which behaves in myExperiment. But people discover stuff, acquire it, which might be payments or licenses or copying or whatever it is. They do some stuff with it and then they do their work. They do their research here. Typically, perhaps, at that point, working with close colleagues, people in the same project, in an open science model, making that available to everyone, we don't have to have that in myExperiment. Then ultimately disseminating and curating this work. And what we're looking at is that life cycle to understand what these research objects are through that cycle, what characteristics that they need. So that's elevating the discussion from what are these types of RDF to actually what is it that researchers are doing in data-intensive science. And a couple of pointers to papers tomorrow. One of those projects on that list was SISMO, which I think Wolfgang is presenting tomorrow. And this is slightly familiar, you see, recognise it after seeing myExperiment interface. This is related to myExperiment, but this involves sharing a different domain. It's quite a spectacular story of a community, not, like I said at the beginning, not necessarily wanting to share, and what we do about that and how we support that through this story. Here's another one, Mark and Steve in the front here, involved in chemistry, the use of blogs for blogging the lab. We heard a paper this morning from Steve about one blog solution. Blog 3 is the one being designed at the moment, and this is being integrated with myExperiment as well. So pointers to the two guys in the front. If we look at the set of projects as they stand, the practice of our Taverna users and our myExperiment users today, these are the sort of characteristics we see. We're calling these first generation technologies. So people are using the tools within their own problem area. We get bits of a few examples of work that's going across areas, not so many at the moment. We see traditional publishing supplemented by these additional pieces to do with data and some of the other aspects like workflows and so on. We see the supplemental materials and all the issues of debate surrounding national decay and national peer review, which we're reading a lot through at the moment. Provenance, we're really good at recording it, not using it at the moment. And science is getting faster, and practice is beginning to shift, with more stuff happening in silico. What the current set of projects is delivering, we believe, is increasing reuse, okay? Increasing use of the tools and data and methods. A great example, some of you will know, of the trypanosomiasis workflow for Paul Fisher being reused, and not in cattle, but in mouse to achieve results that hadn't been achieved for 2 years of work manually. We're beginning to see some reuse of the research objects and recombination of reproducibility. Provenance actually playing a role in how we're doing the science. New practices begin being established. And this important idea that that content of myExperiment isn't just curated by the crowd, but it's curated by experts as well. We're beginning to build a culture of different kinds of stakeholder around that. What we're heading towards, we reckon, in about 5 years, in the vision behind these research objects will be used, is global reuse of the tools and data and methods. That international aspect is actually very important to us. Surfacing the right levels of complexity to the researcher, radical sharing, and we've got this nice bold statement involved, and provenance assisted design, that's very good, isn't it? And the curation is autonomic as well as social, so we're beginning to have an assisted aspect of curation. Curation is hugely important because one of those artifacts, one of those research objects, might work now, it might not work in 3 minutes, or 3 years. We don't have a computer science solution to that problem. The way these things work depend on the changing landscape. The community curation effects, the expert curation effects are vital to that. So to close, instead of the manifest, hacks, resource maps, that's a joke for some of you. Sorry, yes. What is it we're trying to achieve here? It's moving this level of discussion up. So, one of the characteristics, we talk a lot about characteristics of actually tensor science, but one of them, if you like, that's commonly cited that's come up into these discussions already, is we are working with larger teams. We're working with multidisciplinary collaborations. We're working with more sort of ad hoc sharing of things. Not everyone knows everyone. Not everyone is organised within these teams to work in certain ways. So the style of sharing is definitely changing. What we've done with myExperiment, and going through this process of evolution, speaking as half a social scientist, co-evolution, with the people who are using it, we're evolving a social infrastructure for sharing those objects. So that those objects should be really easy to use. There's a huge utilitarian aspect to research objects that isn't well articulated in what we say. It should be very possible to use them very easily, not have to fully understand them, but be fully taught to use them. That's the point about the graceful revelation. And then the papers are just an archaic human readable form of these things. One day you won't be saying to me after the talk and I have a copy of the paper, you'll be saying I have a copy of the research object. Except you won't be saying that. You'll be saying it to me instant message, or actually I already will have tweeted it to you, my laptop has it. So you've already got the research object which describes the presentation you just had. Gosh, I must do that in the next presentation. Yeah. Okay. So that's where we'd like to see the discussion. We're really interested in that. We actually are building up a document at the moment called the Research Object Manifesto. So perhaps in a year's time we can tell you some more about that. Thank you very much. So there are some really good examples of that. This is actually quite a lot of debate. Yeah. Because people want that URI to point to something that's fixed. Yeah. In their life cycle, hacks might be mutable at some point. So in some discussions we find hacks are these things that flow from place to place and they're kind of ephemeral. And in other places, hacks are this persistent lot of stuff and sometimes one does things to it. And those two models are definitely floating around. So there's been quite a lot of discussion about that. Certainly to fit in with the left or right hand side of our individual pictures, DIYs is definitely the way to go. And there are examples of things like workflows with DIY that can be done. I haven't quite done the other myExperiment yet. We're currently trying to get myExperiment to link data compliant, which is quite an interesting challenge in itself, which I want to do better as well. Not as easy as it might be.
So I had a comment about something that was early on in your talk about the role of data. It was when you were discussing whether or not people would share and the orders of magnitude difference between the users and the providers and curators in the middle. So two comments. First of all, in a way it's by a sample. People who aren't interested in sharing aren't signing up for myExperiment at all, I don't think. And so the fact that the majority of people on myExperiment share, the comparison isn't the people on myExperiment who are sharing, it's everybody who can sign up. So,
absolutely.
So it's a very small percentage. But the other point is that judging by the experience with things like Wikipedia and such, I would expect actually the curators to be the smallest group. That is to say, you may have in a particular discipline hundreds of active scientists, and ideally in this future world, all of them uploading and sharing stuff, and then a very much smaller number of people doing curation on that, as opposed to many people curating with a smaller number of people sharing.
That's a really interesting observation. We need to do the analysis. That's great. We can do that study. We need to do it.
No, you're absolutely right. That's right. There's very few people doing curating, and there's people who do contribution.
Right.
Yeah, and of course it's at that world where people who are sharing on it are there because they are using because they believe in sharing. But we're increasingly seeing people who are using it as a private store, and that's a recent phenomenon.
Right.
So then it's been a different kind of community. So so it's interesting. It's a sort of change happening. I don't know why.
Yeah. So I mean, in particular, not interactive or social network analysis, who's looking at the evolution. He finds myExperiment interesting because he's capturing a community that's going through those phases, as opposed to one like NanoHub that's already in a state. Yeah, you see what I mean? I think that's, Karen's absolutely right. That the private store phenomenon, which is actually being amplified by the tooling that makes that easier, is making the number of producers lower than the number of curators, by definition.
You talked about a manifesto for research objects, and clearly there's a cultural change that this site is all about, and how scientists are contributing differently and sharing different points of life cycle. Is there room for a manifesto for the next generation scientists as well? The principles that scientists in the modern age should...
I'm sure the answer is yes, but I do feel a slight charlatanism sometimes, because I can go around to events like this and say, oh yes, in the future people will be using techniques like this, and the next generation is actually important, and we should be changing our practice to do this. But actually, it doesn't make any difference whether I say that or not, really, because it's not happening. Because the next generation scientists don't know any other way. You know, well, my classes that I teach, and I'm sure it's the same for you, don't know a world without the web at all. I refer to a world without Google up there. They have no concept of a world without Google. So I think some of this stuff is going to happen anyway. And actually, what we do for our talks and what we would do for that kind of manifesto is somehow validate that it's okay to be using some of this stuff now. We've had interesting feedback about this. Carol, the PhD student who contacted us to say this is great because our professors wouldn't let us do this, but they makes it okay because you professors are doing it. It's quite interesting.
Because it's not respectable.
It's not respectable.
Yeah, it wasn't. If you're a German academic, it's not respectable. But because I don't give a damn about respectability, it's okay. So I'm going to fly in the face of respectability.
That's it. We should put that on the site. Yeah. So I think we're doing that, and but I hope what we're also doing is, and I've just done a 3.5-foot tour of the US, which again I've seen very far, asking scientists how is the use of research data changing in your area of work, and how do you see it changing over the next few years? You see all these claims about these shifts, but we've really got a handle on now on how things are changing, and they really are changing, absolutely. Different in different disciplines, but there's fantastic stuff going on. So yes, I wonder if we should do that manifesto as well. Very good.
Can I just make a comment about that? Last week I gave a myExperiment talk to BioIT World Expo, which is kind of completely different. It's commercial. It's an invitation from the biotechnology and pharmaceutical companies, and it really rocked. You know, people were really enthusiastic. I've now been asked to speak at the big one in Boston, and this was people from the floor saying we need to open innovation and sharing in pharmaceutical. And this is really unusual, because this is one place where they really care about the data. Absolutely, they really do care, but they understood the measurement methods. And I was really surprised by that. So I really do feel as if there was something going on in the scientific community to do with open innovation, to do with pre-competitive sharing at least, mainly because people just haven't got the money anymore and the know-how to do it in any other way.
But also I think that distinction between really being willing to share the data and being willing to share the methods.
Exactly.
And the fact that you have a workflow which pulls away from the specific data and you can give it to somebody so that you don't have to share all of what you're doing. You can say, this is how I did it, and actually it would be good if we agreed about a better way to do this.
Absolutely. I think we absolutely think on it. That's what I thought. It was because of the method, not data. As soon as you go into data, it's different getting them together.
Actually, I've been talking to a lot of field biologists recently, and they have no problems sharing methods. They're eager to share methods. Yeah, we're a little more reserved about it.
I'm a little bit puzzled by this this sharing of data issue, in that NSF has very clear data sharing policy.
Oh yes.
But let me give you 2 examples of NSF-funded researchers that I've talked to. Example number 1 is I can't really share my data yet to a synthesis effort, but this larger effort, because one of the guys on my team is junior faculty. In order to get tenure, he has to be the senior author on 2 papers, and the only way to get 2 papers out is to do site-specific papers instead of synthesis papers. Okay, that's statement number 1. NSF-funded site. Statement number 2, different NSF-funded site. If you publish a synthesis paper before I've published a paper about my site, our university lawyers have told us that that leaves you open to political suits, because of course carbon's getting too deep, right? So,
Well, but
I agree with you, it's silly.
Well, but I mean, put it this way: if you just call up the program manager at NSF,
They keep funding these guys.
Yeah, I was gonna say, it's a.
There's policy and
it's
there's money.
Well, more to the point, there's policy and then there's enforced policy. So
Exactly.
it is a profound wish of the NSF that you will share your data, but it's not a policy which is backed up with any sanction
Exactly.
if you don't do it.
well, except there is one, is that when you, in a way, it has to be a community enforcement. And
Right,
that is,
exactly. The review panel has to be willing to say, this guy's not a good sharer, don't give him any more
well,
money.
it's, when you review an NSF proposal, one of the things you review is the results of prior work.
Yeah.
And
But in
But
fact,
contributing data and having
Excuse me,
papers tend to be two
you
different
guys
things.
can keep talking.
Yeah, no,
I'm
I'm
just
with you.
being told that Tony's getting anxious. That's the
It is
next
one of these
one.
things I think is in his life.
So,
Changing everything.
feel free to keep talking. I think it's a great dialogue.
You're right. NSF is